So for the, let's see, we are on page, you're on page 7 in your book, and we're continuing and getting started with scientific notation here. 8 billion is 8 times a billion, so it's 8 times 10 to the 9th. That's our scientific notation. And if we want to write 7.9 billion, we can write it out in standard notation, and then we can also write it in scientific notation. And that's what that would look like. If we go to Oregon's population at the time of this writing, it was 4.27 million. 4 million would have 6 zeros after the 4. 4.27 million will have 6 places after the 4. So we can write out the standard notation and the scientific notation for both of these quantities. So this is sort of a friendly warm-up for scientific notation, making it not seem too weird. And then we jump to the US population, so this one's going to be a little different. We've got 333 million. There are 6 places after the 333. Because 10 to the 6th is a million, we could write 333 million as 333 times 10 to the 6th. That's actually fine. It is equivalent to this, but it's not technically scientific notation. So there's a special rule in scientific notation that we want the starting number to be between 1 and 10. I'll get into that a little later. So 10 to the 8th power, let's figure out what number that is. So I wrote down 10 8 times, and that gives me 100 million. And then 3 times 10 to the 8th would be 3 times 100 million, which gets me to 300 million. And then if I do 3.33 times 100 million, now we're getting closer to the US population. So this is scientific notation. The rule is that we need to start with a number between 1 and 10, and then 10 to whatever power will bring us up to our original number. And I think you'll get enough practice with this, even if it's weird at first, that eventually it will just make sense and not be a big deal.